Nice to see you all again. The plan for today is we're going to review the stuff on circuits that we did last week, some characteristics, and then hopefully right towards the end we should be able to get an introduction to the next lab. I do believe you have worksheet 1 that should be due. And hopefully these right now are pretty easy. Maybe a little bit with the electric potential diagrams at the end. Any questions there? I didn't want to take time to do a full whiteboard on that because I really don't think it's necessary on that one. So what I've done is I've typed up an answer key and I've added some notes, some explanations, and it's posted for you on Moodle. So at some point in the next day or so, you want to make sure that you take some time and go through it and compare yours to mine. Okay? That way you'll make sure that you're on the right track with those. All right, so a little bit of review and practice. On this one, it's knowing circuit characteristics. This is serious. Oh, rough crowd this morning. Okay. So I have a list of series characteristics combined and mixed up with parallel ones. I've also got, as you can see, a couple of circuit diagrams and some electric potential diagrams. And just to get us thinking about it again, I'm going to give each one of you one of the cards. I'm going to take the pair, and then if your card gets selected, you simply come up and drag one of the characteristics over to which type of circuit you think it fits with. Does that make sense?
Yes.
Okay. Thanks. Let's see how well you do on this with your notes closed then. Okay? I'll be as impartial as I can. Calvin, what number did you have? 1. The red 4. Who's got the red 4? All right. Sophie, you excuse me, grab one of the characteristics, drag it over to the side that you think it fits with. So parallel, one bulb goes up, the other stay on. I'm going to ask you to draw the next card. That takes the pressure off of me.
7, red 7.
It's kind of nice when you're not the odd number person, isn't it?
Red 3.
You don't have to go in order either. You can grab anyone that you want.
Red 2.
Red 2? There's no red 2. Okay.
Red 9.
9. Bulb brightness does not change as we're at it. The 2.
Black 10.
Here's black 9.
One pass for the charge. Got it.
Red 6.
Black 4. Okay, dimmer, okay. Red ace. You know, you can even scroll down if you want to take one of the circuit diagrams. Anybody wondering about that one? Okay.
Black 8. Red 8. Black 3.
Before we move off of that one, go ahead.
Black 6.
Black 6, you'll be up in just a second. What exactly does this part mean right there?
Just goes over the way.
So they don't intersect, they don't connect. Are we sure that one's series? How could you be absolutely sure? Draw in the path. So the charge starts here or starts there? Top or bottom?
Bottom.
Yeah, based on the way what we decided to do, the convention we're using, we said positive charge from high to low. And then under, over. Good. All right, black 6.
Black ace.
Black 7. I don't think there's anything left. I know. Are there any questions about these characteristics? So we're getting better at differentiating between series and parallel? What do you think your color is at? You're green? Everybody's green? Green and yellow? No reds?
I have a question.
Yep.
What do you mean by bulbs share the electric potential difference?
Yeah, that doesn't make sense. I think those two words have share and
What the electric potential
sorry, I'm not sure.
Well-
that's just describing the equation though, isn't it?
It kind of is, and remember this is defined as the energy per charge. So that's what, excuse me, that's what the energy that each coulomb gets as it's taken from the low potential up to the high potential. It's got a certain value. And it's assuming that it's a series circuit that we're dealing with, that total that we start with gets divided up with each one of the elements in the circuit. Okay with that? All right. Well, the next step then is for us to practice with some schematic diagrams. So I'm going to ask you to take out your notes so you can create some drawings and write some observations down. What I've got for you is, this is an old, probably came out of a bathroom somewhere. I got it from the Habitat Restore. And I just did a little fixing of it. So I want you to ignore these 4 bulbs to start out with. Okay? Just ignore them. Pay attention to these 4. I even have them numbered for you. 1, 2, 3, and 4. They're all the same bulb. They're all 25 watt bulbs. And I'm going to plug its cord in. They'll come on, and I want you to make some observations. Use the characteristics we just practiced. Decide if it's a series circuit, if it's a parallel circuit, and then draw the circuit diagram for it. Here we go. So bulbs 1 and 2, those are pretty bright, aren't they? Can you see that bulbs 3 and 4 are on? I have these cans, I'll cover them up, and then it might be a little bit easier for you guys to see that those are on. Questions for me? You definitely can draw it if you're ready. Otherwise, there's more data you could gather if you want. Yeah?
You could just remove bulb 1.
I would be happy to take bulb 1 out.
Can you take bulb 3 out?
I would be happy to take bulb 3 out.
Can you take bulb 2 out?
Would you like this one back on?
Yeah. Yes.
Bulb 2 out.
Take bulb. Wait.
Bulb 2 and 3 out?
Why?
See if number 1 goes.
Why would it help you to know if... No, go ahead. I'm just, you know.
1 and 2. What?
Take 4 out.
Because you're thinking that these 2 might be wired one way, and you're trying to see if they're connected to these 2.
Right.
Ah, so you want to take one of each out. Either the second one, okay. Which one would you like out?
Number 3.
3.
Number 3?
1 and 2.
Is 2
Do you want this one back on? Okay. Alright, so we'll start from
1 and 2 out.
1 and 2 off. So what does that tell you?
You've got multiple series.
Well, hang on, don't give the words yet. But there's 2 separate circuits. Completely separate. So you're actually going to draw two circuit diagrams. Which two bulbs are in one of the circuits? 1 and 2. These two are on a different circuit. All right, go ahead and draw them. Julia, one more question.
How do you draw one if there's not a battery?
You could either draw it off the other side or just draw a separate battery.
You cannot number
Screw number 1. Okay.
and number 3.
This one should be pretty straightforward just to get you warmed up again. So you've got two separate circuits that you're drawing. Don't forget to number your bulbs. Two separate circuits. Oh, I see. Questions for me? Okay. All over here. Well, hang on a second because.
Yeah, bulbs 2 and 3 aren't connected at all.
Oh, why? Oh, did you just have the one on screen?
Yeah. Yeah, so it's 1 and 2 in one circuit and 3 and 4 in the other circuit.
Right, and then is there another, so that's it, right?
That's it. Two separate circuits. Well, what's the way we could check it? What data did you record when we took one out? Tuesday, because this circuit here tells us if we take one out, what's going to happen with 3? And remember, there's two separate circuits, so 1 and 2 are on one circuit and 3 and 4 are on a different circuit.
So is 1 and 2? 1 and 2 are.
Okay, so that means if I take 3 out of this one, 4 is still right, and is that what we observe?
Is it on the same circuit, but it's so one has stable lead? You're still trying to draw like a separate one for 3?
Yeah.
Yeah, for 3 and 4.
Okay.
You can draw them for parallel.
Well, but they're two separate circuits. So there's only 2 bulbs in each one of your circuits.
Yeah, so it's like the draw and I draw.
There you go.
There.
Oh, I should probably have to know.
Okay, but no, they're both not like that though, are they?
That's how I changed mine. So they're
Well, because look at, see, if this is 3,
I feel like it should be right.
and this is 4, and I take the 3 out, this circuit says what's 4 going to do.
Stay lit, but it went out.
Right.
I don't
So
know why
that
it's
tells us
present
based on that data.
These, I get why they should be
The same
different than
bulbs,
those.
right?
Yeah, I get why, because these ones are the ones where it's V, delta V equals.
There you go. That's right.
3 plus 4 equals.
Any other questions? Is it safe for me to assume that you've all checked with each other? Yeah? All right, so because these are pretty straightforward, for the most part, what type of circuit between 1 and 2? Parallel circuit, good. Because when we took 1 out or when we took 2 out, the other was unaffected. How about between bulbs 3 and 4? Series there. Because when we took one of them out, the other one also went out. It's also nice when you look at all 4 of the bulbs, the fact that they're the same size, they're identical bulbs. Like we saw in our experiment, the same 2 bulbs wired in series are dimmer than the same 2 bulbs wired in parallel. What's the explanation for that?
because each of the ones in the parallel circuit is
Have their own.
the same amount of voltage as the battery, then we're sharing it.
Yeah, so it's a kind of a visual way to see that sharing or not sharing of the electric potential difference. That was the warm-up one. Ready for one that's a little bit more challenging? This one will require more data to be gathered on your part.
No.
Now ignore these. These are all 90-watt bulbs. And again, number for you, 1, 2, 3, and 4. We're going to do the same thing. I'll plug it in. We can make some observations.
Can you cover up one, please?
And I'll dim it just a little bit so that you can see that bulbs,
I see that.
bulbs 3 and 4 are really on. Harder to see without these covered up.
Can you, unscrew two?
Take number 2 out.
Uh-huh.
Are you going to jot some data down?
Yes.
Okay. You want 2 first, or you want bulb 1 first?
Two.
I like two.
Bulb 2 first?
One.
Well, I'm just saying, Lexi, you asked.
Was for two batteries.
So. Now, what have you recorded in terms of data for this?
That they're all at least on some sort of series, but then because you remove 2 and the other 2 get brighter, it's still on some sort of series, but they're wired to bypass each other when they go off.
Well, you're mixing up some observations with some hypotheses, which is not a bad thing. But the data would say that when 2 was out, it was the only one that was out. But the brightness of these definitely changed.
Yeah.
Not only did they change, but we can make an observation about their relative brightnesses compared to each other.
About equal?
Would you like a different one out?
One.
Now you would like bulb 1 out.
Yeah.
Four.
You would like bulb 4 out.
Can you cover 2?
Okay.
Yeah.
Well, there's only one left. Would you like me to take bulb 3 out also?
Sure.
So now they're all 4 back on.
Bulb 2 and 3 out.
I'm going to reserve that one for a little bit. I'm just going to make you work with only 1 bulb out at a time.
It's rude.
We can use 2 bulbs at a time to check once we see all of the diagrams. So on your own now, work on your own for a little bit. And then I'll have you partner up front half of the table, back half of the table, and see if we can agree. Not yet, okay. Questions? Okay. Oh, and I'll mention also, these are all, it's all one circuit. Remember, these were essentially 2 separate circuits. This is all one circuit. Yep. Yeah, go ahead and sign up. Does Bulb one out, okay. Questions? Once you're all finished with your own circuit, go ahead and partner up. Let's do front half of the table, back half of the table. See if we can agree.
So how do you counter that? Well, you're asking the right questions. Should I take this out? Does this happen? So what did we observe when bulb one was taken out of there? Okay, so the question you would ask then is, does this circuit show that when bulb one is out, everything is out? How come it doesn't? I would agree it doesn't.
It is also connected to yours.
Yeah, so if we take this path out, can I still trace that one? Right? But those are the right types of questions to draw the circuit and go back to the data and say, what does this have? Do you have your circuit diagram? And you mutually agreed on it? Okay. So they have shared.
It like,
And then they wouldn't equal
that kind of. I don't like to look at this.
You're saying two is on a series.
I said 3 and 4 are on a series.
Basically, I know that one
One is off
is, if one goes out, then the rest of them go out. So that's the main controller, kind of. So that one for sure has to be a series, and the parallel has to test because
Oh,
when
yeah,
like these
yeah,
go
yeah.
out, like one dims, they're like.
And then you wrote it through it like that though?
So I know that.
So you would have had it, but you just didn't follow
These three
you just didn't follow the data.
Yes.
So we took 3 out.
4 went out and 1 and 2 stayed.
Okay, so here, take that pass out this far.
Because that way, when 2 goes out, it just creates a big series. This is 4, because when 1 goes out, then it doesn't allow the path to continue, so they all go out, which is what I did right there. Yes, all go out, and then 2 goes out, and these ones all equal each other then, because it creates a giant series around it. 3 goes out, 4 goes out with it, and these equal each other because it goes through a simple series. If 4 goes out, 3 goes out with it, and then the series is equal.
Seems logical. Did the rest of you agree?
Yeah, that's what I had. That would make sense.
Let's have you put it up as a table on a whiteboard.
Does somebody have a marker?
Once your table has agreed, let's have you put yours on a whiteboard and then we'll compare each table's thinking.
One of those series Martian
So on 2 would be the same brightness.
Three of us have it this way. One of us is that way.
But then, what is the one be the same? Because they're on series.
Also, it's when?
When are all of them up, I guess?
Two out. Then 1 and 1 would because then 1 and 2 would be the same brightness.
Yeah.
Yeah. When either 3 or 4 is removed?
Yes.
Do you want to see that?
Yeah, and they're the same.
Okay, so when either, the question is what happens to the brightness?
Those 2 relative to each other when 3 is removed.
You think 3 is removed?
And they do even out.
It has to be, this is the diagram. It's not just like a diagram. It's not
What's the question? There's another piece of this. And this kind of sets it up for, I mean, it's perfect. Because it sets it up for I'm disappointed why this one's brighter when they're all on. Because there's something else, there's some piece of the puzzle that's missing.
Then I agree.
And that, and yeah, it's beautiful, that's what sets us up for part of what we're gonna do with the lab. It'll explain why that one is the brightest.
1, 2, on a dual set.
I just didn't know.
On a dual set. They're in the series.
You wanna drop in there,
Yeah. And along those same lines, like when we've been tracing the path, can I do that for a second? If we trace this path,
Lexi, did you say my name?
Yeah, you know.
and then we traced this path,
We should get like an L, you know,
This
how
one.
Alvin always wore that.
Just
Red shirt with the yellow.
The yellow A.
But you
Yeah.
said you're gonna see it.
Just like write a C on the board.
No, but A's look cooler than C's.
once your group is done, let's hang them up and we'll compare them.
Capital A is definitely the coolest letter.
Teamwork.
Oh, that's not even
Look at this A. I like
I don't know. No, I think what my plan is that I'm going to bring health food up Thursday because I want to be. I'm not going to bring food anywhere. I'll just go buy bread.
Okay, let's hang yours up.
Yeah, ours sucks. I have spatial
All right, all of the boards are up. And they all look different, sort of. Well, the farthest one over here looks, well, I just drew it.
It's like you unbend the wire.
Yeah, I just
Exactly. Remember, we're looking to see about the paths. It doesn't really matter how on our board we laid them out, as long as the paths tell us the same thing. So if we take a look at each one of them, if I take one out, that opens up the circuit completely. Everything else is out. And that's the case for every one of those. And if I take, let's say, 2 out of this one, then essentially what does this circuit become?
series.
Reading series. Which means if they're identical bulbs, what about their brightness? They should all be the same. Is that what we observed?
Yes.
Good. Martin?
Does it matter that in that one, bulb number 1 is on the other side?
In terms of the fact that it's connected to the lowest potential? Not really. Not really. Although that is one thing that is a bit confusing is, does the potential all get used up by then? And the overall idea is that it still is on a path. There still has to be a potential drop on its way down, when the charge gets back to where it's going. Now, Eric asked earlier about me taking out 2 of the bulbs at once. I said, well, I'm going to reserve that. If I wanted, without using bulb 1 because we know what happens there, if I wanted to shut the whole circuit off, which bulbs could I take out? So if I were to take out 2, that takes out this chunk of the path. And if I take out 3, that takes out that whole path. So if we loosen up 2 and 3 together, then 1 and 4 should also go out. Let's try that. Sure. So there's 2, bulb 2 out, and we said those should all be the same brightness, 3 in parallel, or excuse me, 3 in series. And we already know that if we take this one out, it's going to take out 4. The question is, does it take out 1? Nicely done. That's the correct circuit diagram. The next step is for you to draw the electric potential diagram for that. So I want you to grab your boards again and agree upon the lettering of the ends of the wire for each one of them. And go ahead and you can work as a team on this one. Those tend to give kids a little bit more trouble, so you can work as a team on those. And then we'll do the same thing. We'll put them up and we'll talk about it.
I got it. I think the drop from A is really big. It's the brightest.
Through the first bulb. Keep your circuit diagram on there so that we can see the lettering of your wires.
Oh, mine is.
Questions on these?
Kyle, do you think the voltage drop from the first bulb is brighter?
Oh, you just said it's finished, right?
No, you have to start it here.
No, I can do
I start all my best. That's a good.
questions?
Started all of it.
Yeah.
I thought you might go down. And then from B it goes to H and then Y.
Halfway.
Yeah.
Could you just extend?
And then C goes down, but make it a smaller
The other
drop.
one's, yeah. Make sure this one drops lower than this one.
No.
The F, which then goes.
Is that the correct date?
I'm gonna say this.
Yeah, it goes to the same.
Nicely said, this thing.
I said I'm gonna say that it's the same. Right? Yeah, when I change my mind.
Questions from here?
This also goes.
I mean, you just want 8 or 4.
Yeah, but
Right? That makes sense.
if we take out this.
How are we supposed to draw it? I thought it goes through.
There.
You draw it since the parallel is off pretty big. So that's supposed to be some extra little funky thing.
Well, think about it in terms of potential. We know that there is a potential drop from B to C.
Yeah.
Because those are wires, is there a drop from C to D? Yeah.
There's this, wait. No. Okay.
How about from C to E? No, the only time there's a drop is if we put something away in it. Okay.
Can we do D? So that
And
goes
then
down
there's
there.
Drop.
the drop in half through this line.
Yes, it does.
It does.
Half of that.
Well, if it were half,
Our buddy's birthday is
how would the brightness of this one compare to the brightness of that one? Right.
So this thing takes up almost all of the energy.
Her birthday's on the 22nd
Leaves
of
a little
May.
chunk of the rest.
I'll keep that in mind. I'm gonna write it in my agenda.
You're the first group
Rachel
to
is really
so far to
excited
read
about
the
her
birthday.
birthday. She's gonna be 2.
We knew that, we were saying it's gonna take up half here, a fourth, and then
I don't know.
but I guess that's just not proportionally correct.
It's why is it?
Because
Right.
this
Well,
one,
if this does a half,
I think.
that means the rest of this is still.
relatively right. So this takes up like
Yeah.
3/4.
Her mom says
Are you following this?
Yeah, yeah. It makes sense.
We can go ahead and hang them up.
More of that. Oh, C, D. And go down like that.
So I've done.
Trade that one. Trade that. Trade that.
Because it occurred to me after I read it, I was like, I didn't look at it.
This goes all the way back.
Oh, yeah, because then it would go. Oh, that one.
Martin said I could just extend the lines.
Yeah, you'll have to. You'll have to.
But
We've got 3 of the boards up, waiting for one more.
What's wrong? You know, I learned like
D to E, yeah.
so fine.
As we're looking at it,
Just put E down.
is there, we all use kind of the same letters,
the same potential cities.
convenient. Yeah, X on the Y.
yeah, that's your G. That's your H.
You notice something significantly different on that last board? Maybe the other, they're suggesting that the potential drop here, which would be across bulb 1, is bigger than everywhere else. Is that the same case here and here? Lexi is saying they should all be the same because they're all the same bulb.
We would argue not because of what we observed, because bulb 1 was just so much brighter than everything else, that if it dropped only by half, then the other ones should be relatively bright and be able to be seen when the lights were still on.
It's also a parallel circuit. So it's going to be bright.
Yeah.
Part of it's parallel. Well, let's go the other direction. Does everybody have these 2 drops the same size? Good. And these 2 have to add up to this one? So if I took my voltmeter and I measured here, and then I measured here, should be the same, but then if I measured across here and here,
Add them together.
those 2 add up to that one. It almost makes it seem, at least this came up in one of the groups, like there's a piece missing to explain why this happens and why it's the brightest.
So there should be a big drop.
There should be a big drop. Right? There's got to be something else going on, right? That we just really haven't quite talked about yet.
Yeah, sure.
Seems like it sets us up for maybe an experiment.